So we'll do fearless factoring, and the title gives it away that this is a perfect square trinomial, but as a student, you may look at that and go, I don't know how I'm supposed to know that's a perfect square trinomial. That just looks like another trinomial to me. I have no idea that's going to end up in this special case. The other thing about it is alphabetically, the y's coming, if we're reading left to right, the y's coming before the x. You may think, hey, I got to rearrange. If that makes you more comfortable, you're more than welcome to, but you do not have to rearrange. We can work with it the way we have it here. You also don't have to recognize that it's a perfect square trinomial. What we're going to do is we're going to look at this as if it is a regular factoring question. We're going to go through the process, and then at the very end, something that will happen will let us know that was a perfect square trinomial. And then at the end of that, I'll give you a hint on how to check for these, but again, it's not something you need to spend time on because you'd have to check every time you factored, and depending how many questions are given to you, it's kind of it's an extra step that's probably not needed. So to start off with our fearless factoring, we're looking for factors of 225. This, I do not know these all off the top of my head, so you may need to give me a hand here. We're going to have y for each of those. 5 goes in. 5y.
5
times 50? No, it would have to be another one because it's going to have to be a 1 at the end of it. So it's going to go in 4, 5. 45 times, I think. We got a calculator handy? We'll verify all these as we go through because there's a few. I believe 15 by 15? I think that's right. You double check that for me if you don't mind. Because 10 won't go. 15 will. The
25.
15. Okay. And 25 should go in also, I believe. How many times does 25 go in? 4, 8. You're right. 9. Awesome. Good. Okay. I'm pretty sure that's all of them just from thinking of my facts of 5 for factors. That's a lot. We have to try a heck of a lot of these for our fearless factoring. More than what we normally do in a question like this. And that is only the first half. We also have the number 36, which also has a lot of factors. You have 1 and 36. Okay. We have 3 and 12. You have 6 and 6. 4 goes in 2 though, doesn't it? 3x. 4 goes in 9 times. And 6 goes in 6 times. Again, a heck of a lot of factors here. Now, if we were to do this... If we were to do this systematically, I would try 1 and 225 and have to go through all 4 of those and crisscrosses, okay? Then I would go to this. But our title kind of give it away. And as long as we're aware that that is a process that we should do to technically check, then that's the steps. You would go through this column, multiply it by here, and multiply the bottom here. And again, our goal is, our thing is so wide here, I didn't even write our goal. Our goal is to get 2 products that are equal to the second term, the middle term there, okay? 180xy. So we need our products to add up to this. If I take a quick glance at this, I'll notice that, I got something that shows that this is a square root. And it turns out that, the second one is also a square root. If you run into this situation, just try those 2 first. Try them out first. If they don't work, then go back through the systematic way of doing it. But if they do work, then we kind of found a shortcut to probably something they're implying for us. I'll talk for after. Okay. So let's try 15 times 6. And then, again, 15 times 6. Luckily, with this one, there's no crisscross to it because they're identical. What is our 15 times 6 there? You want to check that on a calculator?
30.
Is it 90-ish?
Yeah, 90.
Perfect. Yeah, so, and don't forget there's an x and a y to both of these. So 90xy and 90xy. Hey, very quickly, using some inferencing, we figured out that that is going to be those 2 terms. So we jump right to the end of this, and we set it up. We have, that's a little too high. We have 2 brackets. Our first column factors, 15y's, are going to be the first terms in each of the brackets. And then technically 15y was times 6, so I'd have to put it in the opposite bracket, except that Those are the same, no difference. So we're just going to drop them both in.
And they both be positive.
And they'll both be positive. Now, technically I'm done. But in a perfect square trinomial, a teacher will want you to simplify as far as you can. This is where you have to recognize. Okay? Take a look at the first bracket and take a look at the second bracket. Anything interesting about them?
They're the same.
They're the same. Which means I can represent them as a single bracket
And the square root.
to the power of 2. That's it. That's all you need to do. You don't actually have to recognize that it's a perfect square trinomial. You just got to be aware of your final answer. And if you have two brackets that are the same, you go, oh, it turns out this was a perfect square trinomial. So the one thing that if you really want to be able to tell off the bat, you check to see if the first two are square roots. So if they are square roots, if I can find the square root, like an integer value of this and an integer value of this, then I take those two square roots. So 225 y squared, I take the square root of it, turns out it was 15y, okay? Take our third term, square root, 36x squared is 6x. We multiply the two of those together, which we've already done. Turns out that is 90xy. And then when you multiply it by 2, if it is equal to the middle term, 180xy, then it turns out we have a perfect square trinomial. This is like the algorithm to check, but let's say you don't visually know. That means every trinomial you'll ever factor, you're going to start with this. I don't really think there's a point to it. Just go right through the fearless factoring or whatever factoring style you have. And then at the very end, just, try to pay special attention to your answer. Are the two brackets the same? If so, represent them as one. If not, wasn't a perfect square trinomial. Does that